This tape is on complex numbers. All right, by definition, that's all we're going to say about it, is we're going to define the square root of a minus 1 as the letter I. By definition, the square root of a minus 1 is I. Therefore, the square root of a minus 4, the way we work this, is we split it as two numbers multiplied together will give us a minus 4. So we split it as positive 4 and a minus 1. Then we know that the square root of 4 is 2, and the square root of minus 1 is I by definition. So we learn to change square roots of numbers that have minuses in front of them into a number times I. Now this one, we happen to know the square root of 4, so it ends up being 2I. But look at the next example. Here we have the square root of minus 7. We still split it. We don't know the square root of 7, so we have to leave it as the square root of 7. But the square root of the minus 1 does become I. All right, now, the next example on the page there, right straight across, is the square root of 20. Now, instead of me writing it all out, you're supposed to pretty well know how to do this, but we'll talk about it. What I want to show you is that the square root of the minus part becomes the I, and the square root of 20 becomes 2 times the square root of 5. And the way you do that, this splits as 4 times 5. The square root of 4 is 2. The square root of 5 remains the square root of 5. But I want to point out something that I write in the notes, and textbooks don't do this. I do not think it's a wise thing to do this, but you need to get used to this. In the book, you will see things written 2 times the square root of 5, I. They go ahead and put the I at the end of it. Now, that's not too wise sometimes, because sometimes you might get that square root symbol showing over the I. So the safest way to do this is to make sure that you don't put the I at the end of the square root. Put it in front of the square root. That's just a preference, not something that makes it right or wrong. Okay, that's what the square root minus numbers will give us. Now let's look at some examples of what we call complex numbers. See, what I started the tape out discussing what this I is. Now we're going to start kind of back over and say, all right, what a complex number is. And I have the definition written in notes. But a complex number is a number in the form of some number here, plus or minus a number times I. Well, I've been talking about numbers. What I'm saying then is, let's see, we talk about that as being a real number. 4 is a real number. 3 is a real number. I is, let's see, we might have to call it imaginary. So, a complex number is a number in the form of a real number plus or minus a real number times I. It so happens that all numbers are complex numbers. If the number that goes in front of the I is 0, we have what we call real numbers. If the number out here at the front, at the beginning of this, is 0, we have what we call pure imaginary. It's a misnomer. It's not an imaginary number, but that's the way to describe it. That's the way they talk about it. So what I want you to see is right in here. All numbers are in the form of A plus BI. If the B is 0, then we get the numbers that you're used to. Just all kinds of numbers, fractions, whatever. If the A is 0, we get what we talk about as pure imaginary, in case you see that somewhere in the book. When they talk about pure imaginary, it's just the I part of a complex number. And then the last one I have there is notes. It's just saying to you, my preference is to put the I in front of this, not behind it, so it doesn't look like it's underneath the square root. All right, now let's go to some knowledge about I to different powers. Let's look at all these examples that I have there. First of all, I is considered to be I squared. What's I squared? I squared would be the square root of minus 1 times the square root of minus 1. If we take the square root of A times the square root of A, we would get the square root of A squared, which is A. If we took the square root of 2 times the square root of 2, we get the square root of 4, which is 2. So that looks like we could say that the square root of a number times the square root of the same number just ends up being that number. That's a reasoning process. We're going to say this. I just want you to know this. I is equal to I squared. I is equal to I. I squared is equal to minus 1. I cubed is equal to minus I. And I to the fourth is equal to plus 1. Memorize those four. Now I want to show you some reasoning behind them, but still just memorize. I to the first power is I to the second power is a minus 1. I to the third power is a minus I. And I to the fourth power is a plus 1. Several reasons. Number one, I cubed is I squared times I. And what is I squared? Previously, minus 1. So that's where the minus comes from. I to the fourth is I squared times I squared. Well, I squared is a minus 1 times minus 1 is a plus 1. Okay, now I'm going to show you, if you'll have these memorized, if you know these four, then I'll show you a rule that you can handle I to any and all powers. Well, let's look at I to the fifth, right across from there. I to the fifth is I to the fourth times I. What's I to the fourth? Plus 1, so that's I. I to the sixth is I to the fourth times I squared. What's I to the fourth? Plus 1, so that's I squared. But wait a minute, by memory, what's I squared? Minus 1. I to the seventh is I to the fourth times I cubed. What's I to the fourth? Plus 1. What's I cubed? Well, that's by memory, minus I. And I to the eighth is I to the fourth times I to the fourth, which is 1 times 1, which is 1. Oh, well, let's look at something. If I divide this by 4, I get a remainder of 1. Okay? If I divide this by 4, I get a remainder of 2. I to the second power is there. If I divide this by 4, I get a remainder of 3. I to the third power is that. If I divide this by 4, I get a remainder of 0. So that's equal to 1. So here's the trick, or a method. It's not the only method, but here's the method to work I to any power. Look at your notes if you wish, or whatever, and you see these I large powers. So what I will do is say I to the 17 divided by 4. 4 goes in 17 4 times with a remainder of 1, so the answer is I to the first power, which is still I. All right, I to 230, I divide 230 by 4. 4 going to that, what, 5 times? Carry the 3, 4 going to 37 with the remainder of 2. So the answer is I squared, and we know that to be a minus 1. Okay, 67. I to the 67. That would be I to the 67 divided by 4. 4 going to 67. 16 times the remainder of 3. And I to the third is minus I. Okay, I to the 32 is 32 divided by 4 is equal to I to the 0 remainder, which is 1. So in other words, the rule is simply you divide the power by 4. If the remainder is 0, the answer is 1. If the remainder is 3, the answer is a minus I. If the remainder is 2, the answer is a minus 1. The remainder is 1, the answer is I. All right, let's use this now to work a problem. Let's say that we have the number, the square root of minus 75, all cubed. Well, let's see, what could we do here? One thing we could do is we could say, all right, that's minus 1, square root of 25, and square root of 3. That's all cubed. So what's the square root of the 5? 25? That's 5. What's the square of the minus 1? That's I. And square root of 3 we don't know, so we leave them alone. So that's cubed. Now we're going to cube everything. So watch. 5 cubed is 125. I cubed is what? By memory is a minus I. And the square root of 3 cubed is square root of 3 times the square root of 3 times the square root of 3. Square root of 3 times square root of 3 is 3. So this would be 3 times square root of 3. So our final answer is negative 375 times square root of 3. Where? You can put the I there. Or personally, I still like the idea, as in the notes, putting the I here and the square root of 3 last. It doesn't make any difference, and you need to get used to seeing it both places. All right, now let's look at adding and subtracting complex numbers. All right, let's look at adding and subtracting complex numbers. Very simple process, very, very simple process. Here's all there is to it. When you add a complex number to a complex number, you simply add the real part. Remember, I described this as being the real part and this being the imaginary part. So you simply add the real part, so that's 8, and you add the imaginary part. 2i plus 4i is 6i. That's all there is to it. All right, let's add some more. Adding this complex number to this complex number, I add the real part to the real part, so the answer is 7. Add the I part to the I part, that's a minus 3 of these plus 1 of these, which is a minus 2. Okay, next one is we have 4i plus 5 minus I, and here again, you see, you don't just add the first number to the first number. What you're adding is the real part to the real part. Well, the real part here is 0. So 0 plus 5 is 5. And then the I part to the I part is plus 3i. All right, down here. Now you're adding the real part plus, here's the complex number. This doesn't have any I, which means it's a 0. So we add the real, which is 5. And we add the I part, which is 0 plus 2. So we get 2i. That's all there is to add complex numbers. Now let's look at subtracting. Subtracting complex numbers can be done 2 different ways. Number 1 is this. This says subtract. So I'm going to subtract the real part from the real part. 1 from 2 is 1. Subtract 2i from a minus 3i. When you subtract, change the sign and add, so that's a minus 5i. The other way of doing it is to say, all right, I want to remove the parentheses. So minus times this plus 1 is a minus 1, and the minus times the plus is a minus 2i. And now we're back to adding. Add the real part to the real part, we get 1. Add the I to the I, we have a minus 3. Add it to a minus 2, which is a minus 5. All right, let's look at the next one. We're subtracting, so we subtract the real part from the real part. That's a minus 3. And we subtract this I, positive I, from a negative 3i. So change the sign and add, so that makes a minus 4i. Or you can remove the parentheses, change the sign, and add. Get the same answer. All right. Next one. Here we're taking a pure imaginary number minus a complex number. And what are we going to do? We're going to remove parentheses. So I remove the parentheses, and that changes this to a plus. And then I add. So, hey, I don't have any real part here, so that's just a minus 5. And then the I is added to give us a plus 5i. Okay, same thing here. Let's remove the parentheses. Change that to a minus, and real, add the real, 2 minus 3 is a minus 1, and a minus 2i. All right, let's look at 2 other ones. And all this first one is right here is simply several numbers added together. But we can still use the same rule, which is we'll remove the parentheses, and we'll add the real to the real. So there's 3, and a minus 1, that's a plus 2, and a minus 5, that's a minus 3. And then we add the I part, so that's a plus 1, minus 2i, that's a minus I, plus 5, which is a plus 4i. But again, the rule is simply add the real part to the real part, the I part to the I part. All right, let's look at the next one now. And I want you to pick up on this and just kind of remember this statement. It's written there in the notes. And that is 2 things. A number, a complex number, adding to its conjugate. Well, what's a conjugate? The conjugate of a complex number is you change the sign of the I part. So 3 plus 2i, its conjugate is 3 minus 2i. A minus 5 plus 2i is a minus 5 minus 2i. You don't change the sign of the real part. You change the sign of the imaginary part, the I part. Well, if that's true, then that means that whenever I add a number to its conjugate, this is always going to be the opposite sign. So that's going to drop out when you add it, and so it will be just the real part doubled. So if you ever add a number to its conjugate, it'll just be the real part doubled. All right, now let's look at multiplication. We multiply numbers that have i's and that type of thing. So let's start out with the easy one. We'll multiply the real part of a number times the complex number. So we multiply just like regular multiplication. 2 times 3 is 6. 2 times 5 is 10i. No big deal, that's easy. So let's take the next case. What if this is the imaginary part of a complex number times a complex number? Well, I times 3 is 3i. I times I is I squared, so it would be 5i squared. Okay, so it would be 5i, but wait a minute, what is I squared? I squared is a minus 1, so we get a minus 5. So what we do is rewrite this problem as minus 5 plus 3i. That's not the way we had it written here is wrong. It's just that this is the standard form of a complex number. Is that you put the real part first, followed by the I part. All right, let's look at next example. We have 3i times this, so we multiply 3 times 4, that would be 12i. And then this would be a minus 6i squared. But what is I squared? I squared is a minus 1. So minus 1 times minus 6 is plus 6 plus 12i. Alright, so what I'm trying to teach you here then is this. Let's look at the next example. if we have an I part of a number times an I part of the number, you will no longer have an I there. It will come back out as a minus 1. So this would be 15 I squared, but I squared is a minus 1, so the final answer to this problem is a minus 15. So that's what I'm saying to you. When you multiply an I part times the I part, you're going to get rid of the I. It's going to come back to a negative number of times, whatever the rest of the number is. All right, so now let's look at the next one. The next one is by the FOIL method. We now have a full complex number times a full complex number. So we do the first times the first, that's 2. Last times the last, that's, I'm going to go ahead and write it down, plus 12I squared. The inside is a plus 3I. Outside is an 8I. So we have a plus 11I. And now we go back and change, or simplify, whatever you want to call it. What is I squared? I squared is a minus 1. So it's a minus 12. A minus 12 to plus 2 is a minus 10. Plus this 11I. Okay, let's do a couple more for practice. Let's say that we have this times this. That's a minus 8. Okay. Last times the last. We're going to do this in one step from the tape. The last times the last is 15I squared. Positive 15I squared, which makes it a minus 15. And the inside, there's 12I, positive. And the outside is a minus 10I. So that's a plus 2I. And therefore, our answer is a minus 23 plus 2I. Now, let's look at this one over here. Of course, kind of a special case that I want you to, again, pick up on and see a real sharp way of seeing what the answer is. Now, taking this one, notice number times its conjugate. Complex number times its conjugate. Look what happens. First times the first, that's 16. Last times the last, that's a minus, I'm going to go ahead and write it 2 steps, minus 9I squared. And then look what happens. The inside, outside is a minus 12I, plus 12I, drops out. Binomial, where these are the same numbers, opposite sign, ends up being the first one squared minus the last one squared, and the inside terms drop out. But what is I squared? It's a minus 1, so we get 16 plus 9. So that means that a number, complex number, and its conjugate multiplied together will always give you the real part squared plus the imaginary part squared. So any number, complex number times its conjugate is simply the first number squared plus that real part of that I part squared added together. All right, next one. Multiply the first times the first is a minus 4. The last times the last is a minus 9. So we get a minus 13. Minus 13. Well, it's not a conjugate. Conjugate is what? This is supposed to be a minus, opposite signs. So what we'll do is this. I'll factor a minus out of this. Factoring a minus out of this changes it now to conjugate. So my answer is going to be a minus the rule I gave you before. First one squared is 4, plus the last one squared is 9. It's 13, so the answer is a minus. All right, now let's look at division of complex numbers. right, we're going to do division complex numbers now. It's a very simple process, concept. It's a lot of work. What we're going to do is this. We will multiply the top and bottom by the conjugate of the bottom. Conjugate of the bottom. So we'll multiply the top and bottom by the conjugate of the denominator. Remember, when we multiplied the conjugates, we didn't have any more i's, so that's what we want. So top, first times the first is 8. This will be 8. Last times the last is a minus 6. Remember, it would be a positive 6i squared. It's negative 1. And the inside is 12i plus 4 is 16i. Divided by. Now, what was the rule we just got to be doing? Multiplying by complex numbers conjugate is simply the first one squared plus the last one squared. So 16 plus 4, which is 20. So what we get is 8 divided by 8 minus 6, which is 2, plus 16i divided by 20. We will now divide the 2 by the 20. That's 1/10. We'll divide the 16 by 20, reducing is 4 over 5i. So every number comes back to being a complex number. Whether you multiply, add, subtract, or divide, it will come back to being a real number part here, and a real number times I. All right, let's go back now and look at the next example I have there. Very simple idea is what we do. If we have an I in the denominator of a division problem, we multiply the top and bottom by the conjugate. So this would be 2 plus 3i times a minus I times a minus I. So top here, this is a minus 2i minus I squared, a minus 3i squared. This I and this I is going to be a minus 1 times this minus, which would be a plus 3. Divided by I times I is I squared, which is a minus 1 times this minus, which is a plus 1. Then dividing this into both, we get positive 3 because we put this in front and a minus 2i. Very simple process. When you're dividing by a complex number that has an I in it, you multiply the top and bottom by the conjugate of the denominator. All right, next example. Next example is just trying to point out the idea of this. The first thing you should do is you should change I to any power back to one of the 4 cases. I cubed goes back to a minus I. And then we use the rule that says multiply the top and bottom by the conjugate. The conjugate of a minus I, 0 minus 1i, is 0 plus 1i. So we multiply the top and bottom. 1 times I is I, and I times I is I squared times a minus. I squared is a minus 1 times a minus is a plus 1. And so the answer, I'm going to do this now, watch. The answer is 0 plus 1i. Because a while ago I said, when you multiply, divide, add, or subtract complex numbers, you will come back to a complex number. So no matter what, you'll come back to a number here plus something times that. Now, don't bother writing that down when you're doing problems. And you should just write the answer as I. All right, now that's how you do add, subtract, multiply, and divide using complex numbers. Now I want to talk about the next 3 examples in terms of the principal square root of a negative number, just to make sure that we don't fall in the trap that happens sometimes when doing some math with square roots of minus numbers. The square root of minus 5 times the square root of minus 5 is, well, hey, we could just multiply that together. Minus 5 times a minus 5 is a plus 25. The square root of 25 is 5, so we can say the answer is 5. But we can't do that. what we must do with the minus the square root of 5 is change it to I times the square root of 5. And then this one is I times the square root of 5. So we get I squared. And now what is the square root of 5 times the square root of 5? It's the square root of 25. Square root of 25 is 5. So we get 5. But what is I squared? We get minus 5. Which is a good idea. That says to us then that if we multiply the square root of a number times the square root of the same thing, we get what that number is. If we multiply the square root of minus 5 times the square root of minus 5, we get a minus 5. All right, let's look at the next example. Square root of 3 minus 3 times the square root of minus 12. Okay, so this would be I times the square root of 3. I times the square root of 12. That's I squared times the square root of 36. And so our answers are minus 6. The I squared gives us what? Minus 1. The square root of 36 gives us 6. Okay, so we have to be careful of that. So what I'm saying to you basically then is if you have the square root of negative numbers, you get rid of that minus sign there by putting an I out in front of the square root. And then you work with whatever's left underneath the square root sign. Okay, next one. We're going to square this. So that means we're going to write it down twice and do the FOIL method. Okay, first times the first, so plus 1. Last times the last. Wait a minute, I got a mistake in this. What I need is a minus right here. We'll change this over to minus 3. And let me erase this right here. Any trouble? Okay, I'm going to rewrite this as a minus 1 plus I times the square root of 3 times minus 1 plus I times the square root of 3. Okay, the notes are correct. It has a square root of minus 3. I left it off here. Okay, so what I'm saying is what I said above there is that if I have a square root of a minus number, what I want to do is take the minus out in front by writing an I there. Now we'll do the first times the first. So that's equal to plus 1. We'll do the last times the last. Now watch. Be careful with something like this. The square root of 3 times the square root of 3 is 3. I times I is I squared. So that's 3I squared, which is a minus 3. All right, then this is a minus I times the square root of 3, and this is another one of those minus. So that's a minus 2I times the square root of 3. So therefore our final answer is the real parts added, so that's a minus 2 I times the square root of 3. All right, now let's look at where we run across this I bit in working with the quadratic formula. Let's say that we have this equation, x squared minus x plus 2 is equal to 0. We want to find the roots of that, and it won't factor. It won't work the other ways. So we have to use the formula. So we come along and we write the quadratic formula. The quadratic formula would be a minus times a minus 1. So minus this number. Plus minus the square root of the b squared, which is 1. Minus 4 times a, which is the x squared. Times the c, which is the plus 2. All divided by 2 times a, which is 1. So we get x is equal to plus 1 plus or minus the square root of 1 minus 8 all over 2. So we get x is equal to 1 plus or minus the square root of minus 7 all over 2. Write this right up here. Then this is a 1 plus or minus I times the square root of 7 divided by 2. Okay? So let's watch. 1 half divided 2 there, plus or minus square root of 7 over 2 times I. 2 roots. 7 halves I, and 1 minus square root of 7 halves I. Conjugates. Every time, or any time, you find the root of an equation and it comes out to be a complex number, there will be another one there that is conjugate. Complex numbers, in terms of roots of equations, always come in pairs. Find one, say you found the negative part, and the other one would be the positive part. And again, what I said on this tape is all numbers will come back to a form of a complex number. Here's the real part plus the imaginary part. All right, let's look at the last example now. Here we have a equation x squared plus 2x plus 4 equals 0. We want to solve for x using the quadratic formula. It would be a minus 2 plus or minus the square root of the b part squared 4 minus 4 times a, which is 1, times c, which is 4, all over 2 times a. So we get a minus 2 plus or minus the square root of 4 minus 16, all divided by 2. So this is a minus 2 plus or minus the square root of a minus 12, all over 2. And what's the algebra here? This is a minus 2 plus or minus. Now what's the square root of minus 12? Well, it's going to be an I. What's the square root of 12? The square root of 12 is 4 times the square root of 3. So that's 2 times the square root of 3, all divided by 2. So, final answer, I divide the 2 and the minus 2, get a minus 1. Divide the 2 in here, it drops out, so I get a plus and minus I times the square root of 3. And notice again, I have conjugate. I have a minus 1 plus I times the square root of 3, and I have a minus 1 minus I times the square root of 3. So here's where imaginary numbers come in and how you deal with them when you're solving quadratic equations. This concludes the tape of basically the simplest forms of using complex numbers, of adding, subtracting, multiplying, dividing, and some examples where you can be used. The remaining part of this tape will be on some pretty complex concepts of complex numbers.